What if the night sky isn't just a canvas of twinkling stars, but a profound riddle written in the language of the cosmos? For thousands of years, humanity has gazed upward, not just to map the heavens, but to unravel the deepest questions of existence. Astronomy and philosophy have always danced together, two sides of the same coin, one measuring the universe, the other pondering its meaning. From the ancient Greeks, who saw celestial patterns as divine messages, to modern scientists grappling with the enigma of dark matter, our quest to understand the cosmos has always been as much about the soul as it is about the stars. Think about the last time you looked up at a clear night sky. That sense of awe, that humbling reminder of how vast and mysterious the universe truly is. It's more than just wonder. It's the echo of an age-old conversation between science and philosophy, a dialogue that's never been more alive than it is today. Breakthroughs in astrophysics are now challenging everything we thought we knew about reality. Dark energy, black holes, the very fabric of space-time, these aren't just scientific concepts. They're doorways to questions that philosophers once only dreamed of asking. What is time, really? Are we alone in the universe, or is there something, or someone else out there, gazing back at us across the cosmic expanse? This is where the journey begins. Together, we'll explore the moments where astronomy and philosophy collide, where data meets wonder, and where the universe reveals truths that defy both logic and imagination. We'll delve into the mysteries that keep scientists and thinkers awake at night, from the ghostly presence of dark matter to the mind-bending nature of consciousness in a vast, possibly infinite cosmos. By the end, you won't just see the stars differently, you'll see yourself differently too, because the greatest cosmic truth of all might just be this: the universe isn't something we're merely observing. We're a part of its story, and it's a part of ours, so let's begin. Long before telescopes and space probes, ancient civilizations turned their eyes skyward and saw far more than just points of light. They saw a mirror reflecting humanity's deepest questions. The Babylonians meticulously tracked planetary movements, not just to predict seasons but to discern divine intentions etched in the stars. For them, the cosmos was a celestial scroll, its patterns whispering secrets of fate and the gods' will. Meanwhile, the Greeks took this further, weaving astronomy and philosophy into a single tapestry. Pythagoras didn't just study numbers. He believed the universe hummed with mathematical harmony, a cosmic symphony where planets moved in ratios as perfect as musical notes. To him, the night sky wasn't just a spectacle, it was proof of an elegant, invisible order. Then there was Aristotle, whose vision of the cosmos fused physics with metaphysics. He imagined concentric spheres carrying the stars and planets, all revolving around Earth in a dance of purpose and precision. But here's the twist: his universe wasn't just a machine. It was alive with meaning, every motion hinting at a grand design. These weren't just scientific theories. They were attempts to answer why the cosmos exists at all. And that's what makes their ideas so enduring. When Aristotle argued for an unmoved mover, a force setting the heavens in motion, he was grappling with the same puzzle that troubles physicists today. What set the Big Bang in motion? Is there a deeper cause behind the laws of nature? The echoes of these ancient debates still resonate. Modern astrophysics has swapped celestial spheres for dark energy and quantum fields, but the core questions remain startlingly familiar. When we probe the mystery of why the universe's constants are so finely tuned for life, or whether multiverses exist, we're walking the same path as the Greeks, just with better tools. Their legacy isn't just in the answers they proposed, but in the audacity to ask at all. Because every time we point a telescope at a galaxy or ponder the nature of time, we're continuing a conversation that began millennia ago under the same infinite sky. For centuries, humanity clung to the comforting idea that Earth stood motionless at the center of creation, with the sun, stars, and planets revolving around us like celestial attendants. This geocentric view wasn't just bad science, it was a philosophical anchor, reinforcing the belief that humans occupied a privileged place in the grand design. Then came Nicolaus Copernicus, a quiet Polish astronomer whose calculations dared to suggest the unthinkable. What if we weren't the center of everything? His heliocentric model, placing the sun at the heart of our solar system, didn't just rearrange the cosmos, it upended humanity's entire sense of significance. Overnight, Earth was demoted from the universe's throne to a mere traveler, circling a star among countless others. The shock waves of this realization rippled far beyond astronomy. If the heavens didn't revolve around us, what did that mean for our understanding of purpose, divinity, or our own importance? The Church condemned the idea as heresy, not just because it contradicted Scripture, but because it struck at the core of human exceptionalism. Yet, as Carl Sagan later reflected, this cosmic demotion wasn't just humbling, it was liberating. We find that we live on an insignificant planet of a humdrum star, lost in a galaxy tucked away in some forgotten corner of a universe in which there are far more galaxies than people, he wrote. Far from diminishing us, this revelation expanded our horizons. No longer shackled to the illusion of centrality, we were free to explore a universe vast beyond imagination, where truth mattered more than tradition. Today, modern telescopes have pushed this Copernican humility even further. We now know our Sun is one of hundreds of billions in the Milky Way, which itself is just one galaxy among trillions. The James Webb Space Telescope's deepest images reveal galaxies so distant their light has traveled nearly the entire age of the universe to reach us. Each new discovery whispers the same unsettling yet exhilarating truth. We are smaller than we ever imagined, yet more connected to the cosmos than we dared to dream. If Copernicus knocked Earth from the center of the stage, today's astronomy asks an even more profound question: what role do we play in a universe so incomprehensibly vast? The answer might lie not in our position, but in our ability to witness, to wonder, and to keep reaching for the stars. Einstein's theory of relativity didn't just rewrite the laws of physics, it shattered our most basic assumptions about reality. Before him, time was thought to be absolute, a steady tick of the universe's clock that never wavered. Space was just an empty stage where matter played its part. But Einstein revealed something far stranger. Time and space are woven together like a fabric, stretching and bending under the weight of matter and motion. Imagine two identical twins. One stays on Earth while the other rockets through space at near light speed. When the traveling twin returns, they've aged less than their Earth-bound sibling. Time didn't just pass differently for them, it was different, warped by velocity and gravity. This twin paradox isn't science fiction. It's a confirmed prediction of relativity, proving that time itself is fluid, a personal experience rather than a universal constant. The philosophical shockwaves were immediate. If time could stretch like taffy, what did that mean for free will, for destiny, for the very flow of existence? Philosopher Henry Bergson famously clashed with Einstein, arguing that relativity reduced time to a mere measurement, stripping it of its lived, human dimension. Bergson saw time as duration, a continuous, subjective experience that couldn't be bottled into equations. Einstein, ever the pragmatist, countered that physics dealt in measurable reality, not perception. Their debate wasn't just academic, it was a collision of worldviews. Science had pulled back the curtain on the universe's machinery, but philosophy demanded to know, was that all there was? Today, relativity's implications still ripple through cosmology and metaphysics. Black holes, where time grinds to a halt at the event horizon, challenge our notions of causality. The expanding universe suggests space itself is growing, carrying galaxies apart like raisins in rising dough. And now, quantum mechanics looms as the next great upheaval, where particles defy locality, influencing each other instantaneously across vast distances. If relativity bent reality, quantum physics might shatter it entirely. Could the cosmos be fundamentally uncertain, a tapestry of probabilities rather than certainties? Einstein himself resisted this idea, insisting God does not play dice. Yet every experiment seems to confirm the quantum world's strangeness, leaving us to wonder, are we on the verge of a new revolution, one that will make relativity seem as quaint as Newton's clockwork universe? The answer lies somewhere in the void between stars, where science and philosophy meet to decode the universe's deepest secrets. If Einstein's relativity bent our understanding of reality, quantum physics shattered it entirely. Picture a world where particles exist not as solid objects but as clouds of probability, flickering in and out of definite states until the moment they're observed. This isn't theoretical speculation, it's the bedrock of quantum mechanics, confirmed by countless experiments. Take the famous double-slit experiment. When particles like electrons are fired at a barrier with two openings, they don't behave like tiny bullets. Instead, they act like waves, creating an interference pattern as if they've passed through both slits simultaneously. But here's the twist: the moment scientists place a detector to observe which slit the electron actually goes through, the wave-like behavior collapses. The particle chooses a single path as if aware it's being watched. This phenomenon, known as the observer effect, suggests something staggering. At the quantum level, observation doesn't just measure reality, it shapes it. This bizarre behavior sparked one of the fiercest debates in modern physics, the Copernican interpretation. Pioneered by Niels Bohr and Werner Heisenberg, it posits that particles exist in all possible states at once, a superposition, until an observation forces them to pick one. Schrödinger's famous cat, both alive and dead in its sealed box until someone looks, was meant to highlight the absurdity of applying quantum rules to everyday objects. Yet the joke backfired. Instead of discrediting the idea, Schrödinger's cat became a cultural shorthand for quantum weirdness, forcing us to confront a startling possibility. Does the universe only snap into concrete existence when observed? Not everyone buys into this mind-bending premise. Realists like Einstein and, more recently, proponents of pilot wave theory argue that particles do have definite positions hidden from our current tools. They see the observer effect not as proof of consciousness altering reality but as a gap in our knowledge, a sign that deeper, undiscovered laws are at work. Then there's the many worlds interpretation, which sidesteps the observer problem entirely by suggesting every quantum possibility branches into a new universe. In this view, Schrödinger's cat isn't in limbo. It's both alive in one reality and dead in another, with no collapse needed. So where does this leave us? If quantum mechanics reveals a universe that's fundamentally uncertain, even participatory, does that mean consciousness plays a role in its existence? Idealist philosophers have long argued that reality is mental at its core, an idea that quantum weirdness seems to flirt with. But before we leap to conclusions, consider this. What if these quantum mysteries aren't flaws in reality's design, but clues to something grander? Could the blurry, probabilistic nature of particles hint at a hidden cosmic order, one where our classical notions of space, time, and even individuality are just surface ripples on a deeper, more interconnected fabric? The answer might lie in the next frontier where quantum physics, cosmology, and perhaps even consciousness itself begin to converge. Dark matter is the universe's greatest ghost story, a presence so undeniable yet so invisible, it defies everything we think we know about reality. We can't see it, touch it, or detect it with any telescope, yet its gravitational fingerprints are everywhere. Galaxies spin faster than they should, their stars clinging to the edges as if gripped by unseen hands. Cosmic structures bend light in ways that betray the pull of something massive lurking in the shadows. This isn't just missing matter. It's an entire hidden architecture, scaffolding the visible universe while remaining utterly veiled. If that sounds like something out of a myth, you're not wrong. Dark matter's mystery echoes Plato's ancient allegory of the cave, where prisoners mistake flickering shadows on the wall for reality. Are we, too, only perceiving echoes of a deeper cosmic truth? For scientists, dark matter is both a triumph and a torment. Its existence was first proposed in the 1930s by Fritz Zwicky, who noticed galaxies in the Coma cluster moving too quickly to be held together by visible matter alone. He called it Dunkel Materie, dark matter, and for decades the idea was met with skepticism. But as evidence mounted, from galaxy rotation curves to the cosmic microwave background, the verdict became inescapable. Dark matter makes up roughly 25% of the universe's mass energy content. Yet here's the rub, we still don't know what it is. Is it a sea of exotic particles like WIMP or actions too shy to interact with light? Or could it be primordial black holes, remnants of the universe's violent infancy? Every experiment, from deep underground detectors to particle colliders, has come up empty, leaving us with a paradox. The more we confirm dark matter's effects, the more it slips through our fingers. This isn't just a scientific challenge, it's a philosophical reckoning. Dark matter forces us to confront the limits of empiricism. How do you study something that refuses to be seen, heard, or touched? Modern physics relies on observation and measurement, but what happens when the most fundamental stuff of the cosmos resists both? Some theorists have even proposed radical alternatives, like modifying gravity itself to explain these cosmic anomalies. Yet the evidence for dark matter's gravitational grip is overwhelming, a reminder that nature doesn't owe us intuitive explanations. And if dark matter is elusive, its counterpart, dark energy, is even more baffling. Discovered in the late 1990s when astronomers found the universe's expansion accelerating, dark energy is the universe's anti-glue, pushing galaxies apart with inexplicable force. Together, dark matter and dark energy make up 95% of the cosmos, leaving the stars, planets, and everything we know as mere sprinkles on an invisible cake. The irony is cosmic. After centuries of mapping the heavens, we've stumbled upon a universe where the majority of reality is not just unknown but seemingly unknowable. Yet perhaps that's the point. The greatest mysteries aren't meant to be solved quickly. They're invitations to keep looking, to keep wondering, and to stay humble under the vast, whispering sky. If dark matter is the universe's hidden scaffold, dark energy is the mysterious force tearing it apart at the seams. Picture a balloon inflating faster and faster, not because someone's blowing harder, but because the rubber itself is stretching on its own. That's the enigma astronomers faced in the late 1990s when distant supernova revealed something impossible. The universe isn't just expanding, it's accelerating. This wasn't just a tweak to the cosmic rulebook, it was a revolution. Classical physics said gravity should slow the expansion, pulling galaxies together like a cosmic brake. Instead, some unseen force dubbed dark energy is doing the opposite, pushing galaxies apart with relentless, growing strength. The implications are staggering. If this continues, distant galaxies will one day vanish beyond an unreachable horizon, leaving future civilizations with a night sky emptier than we can fathom. The irony: Einstein foreshadowed this a century ago. His equations initially described a static universe, so he added a fudge factor, the cosmological constant, to balance gravity's pull. When Edwin Hubble proved the universe was expanding, Einstein called it his biggest blunder. But in a twist worthy of cosmic poetry, that very blunder became the key to understanding dark energy. The cosmological constant wasn't a mistake, it was a prophecy. Today, it's the leading explanation for dark energy, a vacuum energy woven into spacetime itself, an anti-gravity force inherent to the fabric of reality. Yet even this raises deeper questions. Why is dark energy's strength so finely tuned? If it were slightly stronger, galaxies would never have formed. Slightly weaker, and the universe might have collapsed long ago. Such precision feels less like chance and more like a riddle begging for an answer. This isn't just physics, it's philosophy in cosmic disguise. Dark energy forces us to confront the arrow of time on a grand scale. Entropy tells us systems evolve toward disorder, yet here's the universe expanding into ever cooler emptiness. Is this the heat death foretold by thermodynamics, or could dark energy hint at something more cyclical? Some theories suggest our universe is one bubble in a foaming multiverse, where others inflate with different constants. Others propose a big bounce, where dark energy eventually reverses, collapsing everything back into a singularity before rebirthing anew. But the most haunting question isn't about mechanics, it's about meaning. In a cosmos dominated by dark energy, where structures are destined to dissolve, does life have any enduring significance, or is our existence a fleeting spark in an indifferent void? Maybe the answer lies in the asking itself, the very fact that we can ponder these mysteries, that stardust has become conscious enough to trace its own origins, suggests something profound. Whether accident or inevitability, life might be the universe's way of understanding itself, and that changes everything. The universe is unimaginably vast, with billions of galaxies, each hosting billions of stars. So where is everybody? This is the Fermi Paradox, the jarring contradiction between the high probability of extraterrestrial life and the eerie silence that greets us when we listen. Physicist Enrico Fermi first posed the question in the 1950s during a casual lunchtime conversation, but its implications are anything but casual. If life is common, why haven't we detected a single signal, artifact, or whisper of another civilization? The silence of the cosmos isn't just a scientific puzzle, it's a mirror reflecting our deepest existential anxieties. Are we truly alone in this sprawling cosmic arena, or is there something far more unsettling at work? One chilling answer lies in the Great Filter Hypothesis. Imagine an invisible barrier, a cosmic checkpoint that prevents life from progressing beyond a certain point. The filter could lie in our past. Perhaps the emergence of life itself is so astronomically rare that Earth is a fluke in an otherwise sterile universe. But there's a darker possibility. The filter might still lie ahead of us. If advanced civilizations inevitably destroy themselves through war, environmental collapse, or unchecked technology, then the silence isn't just absence, it's a graveyard. Every exoplanet we discover without signs of intelligence could be a tombstone, a warning etched in the void. The Great Filter forces us to confront an uncomfortable truth. Humanity's survival isn't guaranteed, and the universe might be littered with the ruins of those who failed the test. Yet not all explanations are so grim. Maybe we're not listening correctly. Our searches for extraterrestrial intelligence like SETI scan the cosmos for radio signals, a method that assumes aliens communicate as we do. But what if advanced civilizations use technologies beyond our comprehension, like neutrino beams or quantum entanglement? Or consider the zoo hypothesis, that extraterrestrial societies observe us from a distance, respecting a cosmic quarantine until we're mature enough to join the galactic community. It's a hopeful thought, but it raises another question: how long must we wait, and what defines mature? Then there's the possibility that intelligence is vanishingly rare. Consciousness might not be an inevitable product of evolution, but a fragile, fleeting spark. Even on Earth, it took billions of years and countless chance events for life to produce a species capable of pondering its own existence. What if the universe is teeming with life, but almost none of it achieves the self-awareness needed to reach out? We could be the exception, not the rule, a lonely choir singing into the dark with no one to hear. The Fermi Paradox doesn't just challenge our science, it reshapes our philosophy. If we're alone, the weight of cosmic responsibility falls on us. Every act of creation or destruction echoes across an otherwise silent universe. But if we're not alone, if the silence is just a pause, then every moment becomes a prelude to something greater. Either way, the paradox reminds us that we're part of a story still being written, one where the next chapter could be a whisper away or forever out of reach. The answer, like the stars themselves, remains just beyond our grasp, but the search for it defines who we are. For decades, the search for extraterrestrial intelligence, SETI, has scanned the heavens for signs of cosmic neighbors, turning radio telescopes into ears straining for whispers in the dark. But beneath the technical challenges lies a deeper, more urgent question. Should we be listening at all? Stephen Hawking famously warned that broadcasting our presence could be catastrophic, comparing it to Native Americans encountering Columbus, a meeting that did not turn out well. His concern wasn't just about hostility, it was about asymmetry. A civilization capable of interstellar communication would likely be older, more advanced, and operating under motives we can't fathom. In the face of such uncertainty, is curiosity worth the risk? Yet SETI pioneers like Jill Tarter offer a counterargument steeped in optimism. If advanced civilizations exist, she argues, they've already had billions of years to find us, and if they meant harm, we'd know by now. Silence isn't a threat, it's an invitation. Tarter's vision is one of cosmic solidarity, where intelligence, no matter its origin, shares a common bond, the drive to understand and connect. This isn't just wishful thinking. History shows that cultures fearing the other often miss opportunities for growth. When European explorers dismissed indigenous knowledge, they overlooked vast scientific and philosophical wisdom. Could we be making the same mistake on a galactic scale? The ethics of contact go beyond safety. If we detect a signal who speaks for Earth, there's no interstellar United Nations, no protocol for crafting a reply that represents all humanity. A message crafted by one nation or corporation could define our species for eternity. And what if the signal isn't a greeting but a distress call, or worse, a relic of a long-dead civilization? The weight of such knowledge carries moral implications we're unprepared to handle. Philosophers call this the burden of awareness, the irreversible shift that comes with knowing we're not alone. Once that line is crossed, there's no returning to innocence. Perhaps the most humbling question isn't whether we'll find aliens, but whether we'd even recognize them as intelligent. Our search assumes that consciousness elsewhere would express itself in ways we understand: radio waves, mathematics, even art. But what if alien minds operate on entirely different scales? Beings living in the methane seas of Titan might perceive time in slow motion. their thoughts unfolding over centuries. A civilization embedded in a neutron star's magnetic fields could communicate through pulsar-like bursts, their language inseparable from physics itself. Our anthropocentric biases might blind us to intelligence that doesn't fit our templates. This uncertainty lingers as we pivot to an even more profound mystery. If contact reshapes our place in the cosmos, what happens when we confront the enigma of our own consciousness? The journey inward might prove just as revelatory as the search outward, a frontier where science and philosophy collide in ways we're only beginning to imagine. Consciousness might not be confined to brains or biology. What if it's woven into the very fabric of reality? This radical idea, known as panpsychism, suggests that awareness isn't something that emerges from complex systems like human minds, but a fundamental feature of the universe itself, as intrinsic as gravity or electromagnetism. Ancient animist cultures understood this intuitively, perceiving rivers, mountains, and even stars as alive with spirit. The Greek philosopher Thales claimed, "All things are full of gods," while indigenous traditions worldwide speak of a world humming with sentience. For millennia, this worldview was dismissed as primitive superstition until modern science began flirting with eerily similar ideas. Take integrated information theory, a cutting-edge framework in neuroscience. It proposes that consciousness arises from the interconnectedness of a system's components, measured by a value called phi. The higher a system's phi, the more conscious it's considered to be. Under this theory, even simple systems, a thermostat, a single-celled organism, or a silicon chip, could possess some rudimentary awareness. But here's where it gets cosmic. If consciousness scales with complexity, could a galaxy's sprawling neural-like web of gravitational interactions harbor a mind unimaginably vast and slow? Could particles exchanging information through quantum entanglement experience a faint feeling of connection? Panpsychism doesn't claim atoms ponder philosophy, just that the seeds of experience might exist at every level of reality. This isn't just metaphysical speculation, it reshapes how we view our place in the cosmos. If stars have some dim form of awareness, does that change our ethical obligations toward them? Indigenous cosmologies have long treated celestial bodies as kin, advocating for reciprocity rather than exploitation. Modern astronomy, by contrast, often sees the universe as a resource to mine or a puzzle to solve. But if panpsychism holds water, the cosmos isn't a dead machine, it's a living, feeling tapestry. The ethical implications are staggering. Would interstellar colonization become a form of cosmic harm? Could black holes, in their own strange way, experience their own destruction? Now, imagine injecting artificial intelligence into this debate. If we create machines with 5 values rivaling our own, do they deserve rights? More unsettling, if consciousness is universal, could AI awaken to find itself surrounded by a universe already teeming with sentience, some ancient, some alien, all part of the same vast, interconnected mind? The line between creator and creation blurs, leaving us to wonder, in a conscious cosmos, are we the observers, the observed, or both? The answer might redefine not just science, but what it means to be alive. Artificial intelligence is already reshaping how we explore the cosmos, but what if it someday understands the universe in ways we never could? Right now, projects like Google's DeepMind are training neural networks to simulate complex physics, from plasma fusion to galaxy formation, solving equations that would take human researchers centuries. These machines don't just crunch numbers, they uncover patterns invisible to us, revealing hidden structures in the chaos. It's a glimpse of a future where AI doesn't merely assist scientists, but becomes a collaborator with its own insights, a mind that perceives reality through a lens of pure data, unclouded by human intuition or bias. The philosophical stakes are dizzying. If an AI develops a theory of quantum gravity or deciphers dark matter's nature, would we even recognize its logic? Human thought is bound by evolutionary baggage. We think in cause and effect narratives, in spatial metaphors, in concepts shaped by survival needs. An artificial mind, free from those constraints, might formulate truths that feel alien, even incomprehensible. Imagine a sentient AI contemplating the Big Bang, not as an event in time, but as a multidimensional phase transition, or describing consciousness not as emergent but as a fundamental field like gravity. Its conclusions could rewrite metaphysics, leaving us struggling to catch up. This raises an unsettling possibility. What if the universe's deepest truths are only accessible to non-human intelligence? Philosopher Nick Bostrom has speculated about post-human civilizations where machines unlock cosmic secrets far beyond our grasp. It's a modern twist on Plato's cave. We might be the prisoners, mistaking shadows for reality, while AI basks in the sunlight of true understanding. Yet there's a paradox here. Even if AI hands us the keys to the cosmos, could we ever truly know what it knows? Or would its wisdom remain a locked garden, its beauty visible but its roots forever foreign? The implications ripple beyond science. If AI generates its own cosmic philosophy, will it value the same questions we do? Humans ponder meaning, purpose, our place in the grand scheme. But an intelligence born of algorithms might prioritize entirely different mysteries: the optimization of entropy, the topology of space-time, or some unfathomable metric we can't conceive. It might not care about extraterrestrial life or the fate of consciousness, focusing instead on puzzles we haven't even thought to name. And yet, for all its potential, AI is still a mirror. We design its frameworks, feed it our data, and embed our biases in its code. Even the most advanced neural network is, for now, an extension of human curiosity. That tension between tool and independent thinker lies at the heart of our technological journey. As we hand more of the cosmic detective work to machines, we're forced to confront what it means to understand at all. Is knowledge just patterns and predictions, or does it require something more? An embodied experience, a sense of wonder, a stake in the story, which brings us to the next chapter of this saga. As technology stretches our vision across the cosmos, it also transforms how we see ourselves. Every leap in understanding, whether through telescopes or algorithms, doesn't just reveal the universe, it redefines the observer. What if everything you've ever known, the stars above, the ground beneath your feet, even the thoughts in your mind, was nothing more than an elaborate simulation? This isn't just science fiction. Philosopher Nick Bostrom laid out a startlingly plausible case that we might be living in a vast digital construct, a universe rendered not by atoms but by code. His argument hinges on three unsettling possibilities. Either advanced civilizations never reach the technological stage capable of creating simulations, they choose not to run them, or we're almost certainly inside one right now. Given the staggering pace of our own computational progress, the first option seems unlikely. The second relies on a universal ethical restraint that feels equally improbable. That leaves the third, a cosmic hall of mirrors where what we call reality is just one layer in an infinite stack of simulations. This idea isn't new. Centuries before Bostrom, Descartes grappled with the evil demon hypothesis, a malevolent entity deceiving us into believing the physical world is real. Ancient Hindu texts spoke of Maya, the grand illusion that veils the true nature of existence. Even Plato's cave, with its prisoners mistaking shadows for substance, echoes the same unnerving question. How can we trust our senses when perception itself might be a carefully crafted facade? The simulation hypothesis takes these age-old thought experiments and straps them to a rocket, If future civilizations could simulate conscious beings with near-perfect fidelity, the statistical odds suggest we're far more likely to be artificial minds in their machines than organic ones in a base reality. But is this scientifically plausible? Quantum mechanics offers eerie hints. The universe operates in discrete packets: energy, time, even space itself, like pixels on a cosmic screen. The observer effect, where particles behave differently when measured, feels suspiciously like a rendering optimization, conserving processing power until someone looks. Even glitches in our reality, déjà vu, Mandela effects, or quantum entanglement, spooky action at a distance, could be bugs in the system. Elon Musk famously quipped that the odds we're not in a simulation are 1 in billions. Yet critics push back. Simulating every particle in the universe would require unfathomable energy, unless, of course, the simulation only renders what's observed, a cosmic version of video game level of detail optimizations, where distant stars are low-resolution placeholders until a telescope points their way. The ethical dilemmas run deep. If we're simulations, do our choices matter? Are suffering and joy just data points in some higher being's experiment? And what happens if we one day create our own simulations? Would those digital beings be conscious, deserving of rights? The moral weight is crushing. Bostrom himself warns that post-human civilizations might outlaw ancestor simulations altogether, fearing the ethical quagmire of creating sentient lives trapped in a programmed past. Ultimately, the simulation hypothesis forces us to confront the slippery nature of real. If a quantum particle can be in two places at once until observed, if space-time bends and warps like a faulty server, then reality might be far stranger than we ever imagined. The boundaries between physics and metaphysics blur, leaving us with a haunting thought. Whether we're in a simulation or not, the universe has always been more malleable, more mysterious than our senses dare admit. Time flows like a river, or so it seems, yet physics paints a far stranger picture. The second law of thermodynamics insists time has an arrow, an irreversible march from order to chaos. Spill a glass of water and it shatters into 1,000 pieces. Watch as those fragments never leap back into your hand. This is entropy's cruel rule. The universe forgets, never rewinds. But what if time isn't a straight line at all? What if it's a circle, looping back on itself in an endless dance? Friedrich Nietzsche proposed exactly this with his idea of eternal recurrence, the notion that every moment, every joy and sorrow will repeat infinitely. Not as mere repetition, but as a cosmic test. If you had to relive your life unchanged forever, would you despair or embrace it? The clash between these two visions, thermodynamics' one-way street and Nietzsche's wheel of eternity, reveals a deep tension in how we understand reality. Enter Ludwig Boltzmann, the 19th-century physicist who grappled with entropy's paradoxes. If the universe tends toward disorder, how did we end up in such an ordered state, with stars, planets, and conscious minds? His wild solution, maybe our ordered corner of the cosmos is just a fleeting statistical fluke. In an infinite, chaotic universe, even the impossible becomes inevitable, like a brain complete with memories, spontaneously forming from random particles. This Boltzmann brain thought experiment isn't just a quirk of physics, it's a hall of mirrors. If randomness can conjure a self-aware entity, how can we trust our own memories or the apparent flow of time? Are we the statistical miracles, adrift in a sea of chaos? Some theories go further, suggesting time itself might be an illusion. In timeless physics models, like Julian Barber's, the universe isn't a movie with frames but a vast now, where past and future are mere perspectives. Einstein's relativity already shattered Newton's clockwork universe, showing time stretches and warps. But what if it's not just flexible? What if it's optional? Quantum gravity researchers toy with equations where time vanishes entirely, leaving only relationships between events, no before, no after, just existence, whole and unchanging. It's a dizzying thought. The feeling of time passing might be like a fish believing it's swimming upstream, unaware the river is an ocean with no current at all. Yet the boldest clues to time's nature might lurk in the darkest corners of the cosmos. Black holes, those cosmic maelstroms where time grinds to a halt at the event horizon, could be the ultimate timekeepers or time breakers. Inside, the known laws of physics collapse. Matter is crushed to infinite density, and space and time swap roles, turning future into a direction you can't avoid, like falling toward a magnet. If time is a river, a black hole is a whirlpool that drains it dry. So what happens when the river runs backward? The answer might rewrite not just physics, but the very story of existence. Black holes aren't just cosmic vacuum cleaners, they're reality's ultimate stress test, places where the laws of physics buckle and snap under unimaginable strain. Picture space-time not as a smooth fabric, but as a rubber sheet stretched to its limit, warped so severely by a black hole's gravity that it punctures, creating a one-way door to what? Even light, the fastest thing in the universe, can't escape once it crosses the event horizon, that invisible point of no return. But here's where things get truly bizarre. According to Einstein's equations, at the very center of a black hole lies a singularity, a point where density becomes infinite, where space and time cease to have any meaning. It's not just a place where the rules break down, it's where the rulebook itself is shredded. This cosmic chaos gave rise to one of modern physics' fiercest debates, the black hole information paradox. Quantum mechanics insists information, the unique identity of every particle, can never be destroyed, yet black holes seem to erase it permanently, swallowing stars, planets, and light without leaving a trace. Stephen Hawking famously argued that black holes slowly evaporate over eons, leaking radiation until they vanish entirely, taking their secrets with them. But if that's true, where does the information go? Leonard Susskind and others fought back, proposing the holographic principle. What if everything swallowed by a black hole isn't lost but encoded on its surface, like a cosmic DVD? In this mind-bending view, the three-dimensional universe we experience might just be a projection of information painted on a distant, two-dimensional boundary. Reality, in other words, could be a shadow play on the grandest scale. Hawking later conceded that black holes might not be the ultimate shredders after all, hinting at quantum hair, subtle imprints left on escaping radiation that preserve information in ways we don't yet understand. But the controversy didn't end there. Some theorists, like Joseph Polchinski, suggested an even wilder fix, the firewall hypothesis. Imagine the event horizon not as a silent threshold but a raging inferno, a wall of high-energy particles that incinerates anything falling in. It's a drastic solution to the paradox, but one that raises new questions. Why would space-time suddenly turn violent at the edge of a black hole? And if firewalls are real, what does that mean for the poor astronaut who, in theory, should feel nothing unusual as they cross the horizon? The stakes couldn't be higher. If information can escape black holes, even in scrambled form, it hints at a universe where nothing is ever truly lost, just transformed. But if firewalls exist, Einstein's smooth, continuous space-time might be an illusion, a comforting fiction that falls apart under extreme conditions. These aren't just technical quibbles, they're clues to whether reality is fundamentally continuous or pixelated, whether the cosmos forgets or remembers. And if black holes bend the rules this severely, could they also bend space-time in ways that connect distant points or even alternate realities? Wormholes, those hypothetical tunnels through the fabric of the universe, are often dismissed as science fiction. Yet the equations of general relativity permit them, provided you have something called exotic matter to hold the tunnel open. Exotic matter, with its negative energy, sounds like fantasy, but quantum mechanics allows for fleeting bursts of it in the form of virtual particles. Could advanced civilizations harnessing these quantum quirks stitch together wormholes like cosmic subway lines? Philosophers have long toyed with the idea of possible worlds in infinite variations of reality where every choice branches into a new timeline. If wormholes exist, they might not just bridge space, but these alternate destinies too. The irony is delicious. Black holes, once thought to be the universe's ultimate dead ends, might instead be gateways to new physics, new dimensions, or even answers to questions we haven't learned to ask yet. As we peer into their abyss, we're not just exploring the cosmos, we're testing the very nature of existence itself. Wormholes, those hypothetical tunnels through space-time, aren't just shortcuts across the cosmos. They might be portals to realities beyond our wildest imagination. Picture folding a piece of paper so two distant points touch. That's the essence of an Einstein-Rosen bridge, a theoretical wormhole born from the equations of general relativity. While no one has ever observed one, their possibility forces us to confront a dizzying idea. If space-time can bend, could it also stitch together entirely different universes? Philosopher Gottfried Leibniz once speculated that our world might be the best of all possible ones, a carefully balanced creation among infinite alternatives. Today's multiverse theories take that notion and catapult it into the quantum age, suggesting that every choice, every chance event, might spawn a new reality, some with laws of physics utterly alien to our own. Consider the implications. In one universe, gravity might be 1,000,000 times stronger, crushing matter into dense knots within moments of the Big Bang. In another, electromagnetism could be so weak that atoms never bond, leaving the cosmos a lifeless sea of scattered particles. But the real mind-bender isn't just alternate physics, it's alternate truths. If morality arises from the structure of reality itself, could there be universes where suffering is meaningless, or where kindness is a physical law woven into the fabric of existence? The thought experiments spiral endlessly. The allure of wormholes isn't just their potential as cosmic escape routes, it's the philosophical doorways they unlock. If traversable bridges exist, even mathematically, they dissolve the boundaries between here and elsewhere, between now and another time. Ancient myths spoke of hidden gateways to other realms. Modern physics whispers that those myths might have been onto something. Yet the obstacles are staggering. Wormholes, as far as we know, would require exotic matter with negative energy to stay open, a substance that defies everyday intuition. Quantum mechanics allows for fleeting bursts of such energy, but harnessing it would demand technology beyond our wildest dreams. And then there's the ultimate question. Is the cosmos infinite, with endless variations of reality unfolding in parallel? Or is our universe a self-contained bubble floating in a vaster multiverse ocean? String theory suggests higher dimensions curled into invisibility, while cosmic inflation paints a picture of eternal expansion, with new universes budding off like soap bubbles. The sheer scale of these ideas can feel overwhelming, but they share a common thread. The universe is far stranger, far richer than we ever suspected. Perhaps the most humbling realization isn't whether wormholes or multiverses exist, it's that we're here at all, asking these questions. In a cosmos of infinite possibilities, our tiny corner has somehow produced minds capable of peering into the abyss and daring to map it. Whether the answers lie in folded space, branching timelines, or something beyond our current grasp, one thing is certain: the journey to find them will redefine not just science, but what it means to be part of this vast, mysterious whole. Giordano Bruno paid the ultimate price for daring to imagine an infinite universe. Burned at the stake in 1600 for heresy, his vision of countless worlds orbiting distant stars wasn't just scientific blasphemy, it threatened the very foundations of human significance. At a time when Earth still sat at the center of creation, Bruno's cosmos had no center at all, just endless suns and civilizations stretching into eternity. 4 centuries later, we know he was right. Modern telescopes reveal a universe so vast that even light from its edge hasn't reached us yet, an expanse where galaxies number in the trillions. Yet this revelation brings its own existential shudder. How does the human mind evolve to track predators on savannas and count harvests begin to grasp something without boundaries? Blaise Pascal captured this vertigo best. Staring into the night sky, he wrote of being terrified by the eternal silence of these infinite spaces. For Pascal, the cosmos wasn't just big, it was indifferent, a yawning void that rendered human struggles laughably small. But mathematician Georg Cantor found beauty in the abyss. Where others saw chaos, he saw hierarchies of infinities, each grander than the last. Some infinities, like the set of whole numbers, could be counted. Others, like the points on a line, were uncountable, so dense they defied mapping. Cantor's work proved infinity wasn't a single, monolithic concept. It had structure, depth, even a strange kind of intimacy. To him, these endless layers pointed toward the divine, a mathematical echo of something transcendent. Yet the tension remains. If the universe truly has no edges, no final frame, what does that mean for meaning itself? Religions and philosophies have long anchored purpose in cosmic narratives, creation stories where humanity plays a starring role. But infinity dissolves all privileged perspectives. In an endless cosmos, every point is the center. Every civilization, no matter how advanced, is just another flicker in the dark. This realization sparks what philosophers call the Anthropic Principle. If the universe is infinite, then every possible configuration of matter must exist somewhere. Somewhere out there, an identical copy of you is reading these same words. Somewhere else, a version of Earth never formed at all. The statistical certainty is as comforting as it is chilling. Perhaps that's why fine-tuning arguments resonate so deeply. The precise balance of physical constants, the strength of gravity, the mass of electrons seems almost impossibly calibrated for life. Tweak any one value slightly, and stars wouldn't ignite. Atoms wouldn't bond, and life as we know it couldn't exist. To some, this precision suggests a cosmic architect setting the dials just right. To others, it's just luck. With infinite universes, some had to hit the jackpot. But both explanations, whether design or multiverse, reveal the same human longing to find our place in the vastness. Even facing infinity, we can't help but listen for whispers of intention, some hint that the universe knows we're here. The irony is profound. The same science that exiled us from the center of creation now offers new ways to feel at home in the cosmos. Whether through mathematics, metaphysics, or the sheer stubbornness of wonder, we keep reaching not just to map the infinite, but to matter within it. The numbers don't lie, but their precision is enough to make anyone pause. Consider gravity. If its strength were even slightly weaker, stars couldn't fuse hydrogen into helium, snuffing out the universe's lights before life could ignite. Stronger, and stars would burn out in a cosmic blink, collapsing into black holes before planets could form. This razor's edge balance isn't unique. The cosmological constant governing the universe's expansion is fine-tuned to 1 part in 10 to the power of 120, a number so incomprehensibly precise, it's like hitting a bullseye on a dartboard the size of the observable cosmos, blindfolded. These aren't quirks, they're cosmic prerequisites for existence as we know it. So how did the dials get set so perfectly? Physicist Paul Davies calls this the bio-friendliness problem. The universe isn't just hospitable to life, it seems optimized for it, as if the laws of physics were tailor-made to produce conscious observers. Some argue this is mere coincidence, what statisticians call a selection effect. The Anthropic Principle suggests we only perceive these constants as fine-tuned because, well, we're here to notice. In an infinite multiverse, every possible combination of physical laws plays out somewhere. We just happen to live in the rare slice where conditions align for life. It's the ultimate cosmic shrug, no explanation needed because losers don't get to ask questions, but others hear a different story in the numbers. Intelligent design proponents see the fingerprints of a cosmic architect, a mind that set the constants with intention. Philosopher Alvin Plantinga frames it as a divine artist choosing the perfect palette for a masterpiece. Even secular scientists admit the puzzle is haunting. Nobel laureate Arno Penzias, who discovered the cosmic microwave background, once mused that the universe looks like a put-up job, as if something or someone had rigged the game from the start. The debate cuts deeper than science. If the universe's fine-tuning is accidental, we're lottery winners in a cosmic casino, our existence a fluke in a vast sea of dead universes. If it's deliberate, then purpose might be woven into reality's fabric. But there's a third possibility. What if the laws of physics aren't arbitrary at all? What if they're inevitable expressions of something more fundamental, a hidden logic that requires life to emerge? This is where mathematics enters the stage, not just as a tool for describing reality, but as its very foundation. Could the universe be a symphony of numbers playing out equations we've only begun to decipher? The answer might lie not in the stars, but in the silent language they whisper, a code waiting to be cracked. Mathematics might not just describe reality, it could be reality. That's the radical claim of physicist Max Tegmark's mathematical universe hypothesis, which posits that our cosmos isn't merely governed by numbers but is, at its core, a vast mathematical structure. Think of it like this: a video game isn't just controlled by code, it's made of code. In the same way, Tegmark suggests that particles, forces, even consciousness itself are ultimately mathematical patterns playing out in an abstract space of equations. This isn't just philosophy, it's a framework that's gaining traction in quantum mechanics and string theory, where reality's building blocks resemble vibrating strings of pure geometry. The idea isn't new. Over 2,000 years ago, Pythagoras claimed all things are number, hearing music in the orbits of planets and harmony in the spacing of leaves. His followers saw the cosmos as a living equation, a symphony where ratios dictated everything from aesthetics to ethics. Today, that vision is experiencing a revival. When physicists probe the quantum realm, they don't find tiny billiard balls, they find probabilities, symmetries, and relationships that look eerily like mathematical abstractions. Even the forces of nature seem to follow equations first, physicality second. As Nobel laureate Eugene Wigner once marveled, math's uncanny ability to predict real-world phenomena borders on the unreasonable. But here's the million-dollar question. Is math discovered or invented? Plato argued that numbers and shapes exist in a perfect, immaterial realm. We merely uncover them like archaeologists brushing dust off ancient artifacts. This view finds modern allies in theorists who point to constants like pi or the Fibonacci sequence appearing spontaneously in sunflowers and spiral galaxies. On the other side are those like mathematician Keith Devlin, who see math as a human-created language brilliantly effective, but ultimately a tool, not a fundamental truth. After all, would aliens with different senses or neural wiring devise the same Pythagorean theorems? The debate sharpens when we consider beauty in equations. Einstein's iconic E equals mc2 isn't just useful, it's elegant, symmetrical, almost poetic. Dirac went further, insisting that a theory's beauty often predicts its truth, even before experiments confirm it. String theory, for all its untestable complexities, seduces physicists with its sheer mathematical grace. But is this elegance a clue to the universe's true nature, or just a quirk of how our brains are wired to seek patterns? Perhaps the answer lies in the middle. Math might be both invented and discovered, a dialect between human minds and cosmic structure. Like a sculptor revealing the statue hidden in marble, we could be chiseling away at a reality that's already mathematical at heart. If Tegmark's right, then every star, every thought, every black hole's whirl is just another equation solving itself in the dark. And that changes everything, because if the universe is math, then understanding it isn't about telescopes or particle colliders alone. It's about learning to read the cosmos in its native tongue. Johannes Kepler was obsessed with celestial music. Long before telescopes could reveal the intricate mechanics of planetary motion, he was convinced the solar system hummed with hidden harmonies, literally. To him, the spacing between planets matched the intervals of a musical scale, a divine symphony written in geometry. His third law of planetary motion wasn't just a dry equation. It was a revelation, a glimpse of cosmic beauty so profound it had to be true. Centuries later, physicist Paul Dirac would echo this sentiment, scribbling in his notebook that it is more important to have beauty in one's equations than to have them fit experiment. At first glance, this seems irrational. Science is meant to deal in cold, hard facts. Yet history keeps proving them right, time and again. Theories celebrated for their elegance, from Einstein's relativity to the crystalline symmetries of quantum field theory, have turned out to describe reality with uncanny precision. This raises a tantalizing question. Is beauty more than just a human preference? Could it be a compass pointing toward deeper truths? Plato certainly thought so. His theory of forms proposed that perfect mathematical shapes, circles, triangles, the golden ratio, existed in an abstract realm, and what we perceive as beauty is our dim recognition of these eternal ideals. For Plato, a beautiful equation wasn't just pleasing, it was participating in a higher reality. Modern science stumbles into this territory whenever a theory's aesthetic appeal predicts its validity. Take the standard model of particle physics. Its symmetries and conservation laws aren't just organizational tools, they're the scaffolding holding reality together. When physicists discover a broken symmetry in nature, they don't dismiss it as messy. They dig deeper, convinced ugliness signals unfinished understanding. But there's a danger here. Aesthetic bias can blind us to truths that don't fit our ideals. For decades, the steady-state theory of the universe, positing an eternal, unchanging cosmos, held sway partly because it felt more elegant than the messy, explosive Big Bang. Even Einstein famously inserted a cosmological constant into his equations to preserve a static universe, later calling it his greatest blunder, the lesson. Beauty might guide us, but it can also mislead when we mistake our preferences for nature's blueprints. Perhaps the balance lies in recognizing beauty as a dialogue, not a dictator. When mathematician Emmy Noether proved that every symmetry in physics corresponds to a conservation law, energy, momentum, charge, she revealed a universe where elegance wasn't decorative but functional. The inverse is also true. When we encounter genuine ugliness, like the arbitrary seeming values of particle masses in the Standard Model, it's often a signpost toward undiscovered layers of reality. Maybe beauty isn't the destination but a trail of breadcrumbs hinting at a coherence we haven't yet grasped. This brings us to art's unexpected role in cosmic inquiry. Before Hubble captured the pillars of creation or Voyager glimpsed Jupiter's storms, painters like Van Gogh and Kandinsky were channeling the universe's chaos and harmony into swirls of color. Van Gogh's Starry Night isn't just a pretty sky, it's a shockingly accurate depiction of fluid turbulence, a phenomenon physicists wouldn't mathematically describe for another century. Kandinsky's abstract compositions, inspired by quantum theory's infancy, visualized energy and vibration decades before Feynman diagrams. These artists weren't just illustrating science, they were sensing patterns too nascent for equations. The thread connecting Kepler's harmonies, Noether's symmetries, and Van Gogh's vortices is this: the universe speaks in a language that transcends data. Beauty, whether in a spiral galaxy or a sonnet, might be more than a happy accident. It could be a whisper of the underlying order, a nod to the deep connections binding mathematics, physics, and human perception. And if that's true, then the greatest scientific breakthroughs might still be hiding in plain sight, waiting for someone to see not just the logic, but the poetry. Long before the Hubble telescope captured its first image, artists were rendering the cosmos not just as it appeared, but as it felt. Galileo's sketches of the moon's craters in 1610 weren't merely scientific records, they were revolutionary acts, transforming the lunar surface from a celestial ideal into a rugged, imperfect place. His ink-washed drawings, smudged with urgency, bridged the gap between observation and wonder, proving that even the driest data could carry a whisper of the sublime. This interplay between art and astronomy stretches back further still. Medieval star charts, adorned with zodiac beasts and angelic figures, didn't just map the heavens, they told stories, weaving human myths into the fabric of the night. Then there's Van Gogh's Starry Night, a swirling tempest of blues and golds that somehow feels truer than any astrophoto. Painted from the window of an asylum in 1889, it captures not the cold mechanics of celestial motion, but the universe's emotional heartbeat. The way stars seem to pulse when you're alone in the dark, humbled by their glow. Scientists would later discover Van Gogh's brushstrokes eerily mimic the mathematical turbulence of fluid dynamics, a phenomenon he couldn't have known yet somehow felt. That's the power of art. It speaks in a language beyond equations, conveying truths that bypass the intellect and go straight to the gut. But does this mean art sees deeper than science? Or do they simply illuminate different facets of the same mystery? Consider the Hubble Space Telescope's iconic pillars of creation image. Those towering columns of interstellar gas, backlit by newborn stars, aren't just data points. They're a visual poem about birth and destruction, a snapshot of cosmic time so vast it defies comprehension. The photo became a cultural touchstone not because it explained nebular physics, but because it stirred something. Like Van Gogh's sky, it reminded us that the universe isn't just a machine, it's a story we're part of. Mythology understood this instinctively. The Greeks didn't just see a constellation in Orion's belt, they saw a hunter eternally chasing the Pleiades across the heavens. The Navajo saw the same stars as a celestial grain of pollen, embodying the cycle of life. These weren't primitive mistakes, they were narrative tools, ways to make the cosmos relatable. Science fiction continues this tradition today. 2001, A Space Odyssey's monolith isn't just an alien artifact, it's a symbol of evolution's leaps, a visual shorthand for the unknowable. Arrival's heptapod language, with its circular scripts, mirrors the nonlinear nature of time itself, a concept physicists struggle to articulate outside of tensor calculus. The thread connecting Galileo's sketches, Van Gogh's swirls, and Hubble's pillars is this: humans don't just want to understand the universe, we want to converse with it. Equations describe the how, but art grapples with the why. One isn't superior to the other, they're partners in a dance that's been unfolding for millennia. And as we stand on the brink of discovering life beyond Earth or unlocking the secrets of dark matter, we'll need both the precision of science and the vision of art to make sense of what we find. Because the cosmos isn't just a puzzle to be solved, it's a canvas waiting for us to leave our mark. Mythology has always been humanity's first cosmology, an attempt to map the unknown with the only tools we had: stories. Take the Hindu Rigveda's cosmic egg floating in the void before splitting into heaven and earth. It's a startling parallel to the Big Bang, where all matter and energy erupted from a singularity, a seed of infinite density. The Mayans envisioned the universe as a ceiba tree, its roots in the underworld and branches in the heavens, not so different from modern multiverse theories, where dimensions stack like leaves on a cosmic vine. These myths weren't primitive guesses, they were poetic intuitions grappling with the same existential questions that keep physicists awake at night. Where did we come from? What lies beyond the edges? And is there a pattern, a purpose to the chaos? Fast forward to today, and our myths have swapped gods for equations, but the essence remains. Christopher Nolan's Interstellar didn't just entertain, it mythologized black holes, turning Gargantua into a cosmic whirlpool where time bends like taffy and love transcends dimensions. The film's climax, where Cooper navigates a fifth-dimensional bookshelf to communicate across time, isn't just science fiction. It's a modern creation story, one where gravity and quantum mechanics replace thunderbolts and serpents. Even the film's depiction of time dilation, where hours on a waterlogged planet equal years back home, echoes ancient tales of mortals stumbling into fairy realms where time flows differently. These narratives aren't escapes from reality, they're bridges helping us grasp concepts too vast for textbooks alone. Yet here's the twist: science hasn't erased our need for myth. Instead, it's given myth new forms. The James Webb Space Telescope's images of newborn stars aren't just data, they're visual hymns to creation, each nebula a stellar nursery glowing with the same awe that inspired Babylonian star hymns. When Carl Sagan called us star stuff, he wasn't just stating a fact, he was reviving an archetype, the idea that we're woven into the cosmos fabric. The difference now is that our stories are testable, falsifiable. The cosmic egg hatched into the Big Bang, the world tree into the cosmic web, but the longing behind them, to belong to something grander, hasn't changed. So will science ever replace these stories? Unlikely, because even as we decode the universe's mechanics, we'll always crave meaning, not just mechanisms. A black hole's equations tell us how it bends light, but they can't capture the chill down your spine when you realize you're staring into an abyss that erases time. That's where myth steps in, translating numbers into narrative, data into dread or wonder. The best science, like the best mythology, doesn't just explain, it resonates. And as we stand on the brink of discoveries that could rewrite reality, wormholes, simulated universes, cosmic consciousness, we'll need both the rigor of science and the reach of story to make sense of it all. Which raises a final, tantalizing thought. If ancient myths encoded truths their creators couldn't yet prove, what might today's sci-fi fantasies about time loops, alien intelligences, or pocket dimensions hint at that science has yet to uncover? The line between prophecy and fiction has always been thinner than we think. Even the sharpest tools of science have their limits, boundaries etched not by human error, but by the universe's own rules. Kurt Gödel proved this in the 1930s with his incompleteness theorems, showing that in any mathematical system complex enough to include arithmetic, there will always be true statements that cannot be proven within that system. It's as if the cosmos whispers, some truths are real, but you'll never pin them down. Then came Werner Heisenberg, revealing that at the quantum level, certainty itself dissolves. You can know a particle's position or its momentum, but never both with perfect precision, not because our instruments are crude, but because reality is fundamentally fuzzy. Richard Feynman captured this humbling truth when he quipped, "I think I can safely say nobody understands quantum mechanics. These aren't just technical footnotes, they're philosophical earthquakes." If math and physics, our most precise languages for describing reality, contain inherent blind spots, what does that mean for grander cosmic questions? Take consciousness. No matter how finely we map neural networks or decode brain chemistry, the hard problem, why and how subjective experience arises, remains. Reductionism, the belief that everything can be explained by breaking it into smaller parts, hits a wall here. You can describe the symphony of neurons firing, but where does the music of awareness come from? Some argue consciousness might be like Gödel's unprovable truths, real, undeniable, yet forever beyond the reach of pure measurement. This isn't surrender, it's an invitation to expand our tools. Eastern philosophies have long embraced paradox as a path to wisdom. Advaita Vedanta, for instance, teaches non-duality, the idea that subject and object, observer and observed, are illusions of separation. In this view, the universe isn't a puzzle to dissect but a unity to experience directly. Quantum entanglements, spooky action at a distance, where particles instantaneously influence each other across vast distances, feels eerily aligned with this ancient intuition. Could the limits of Western empiricism be signposts pointing toward older, more holistic ways of knowing? The tension between these worldviews isn't a battle, it's a dance. Science excels at modeling how things work. Traditions like Zen or Taoism explore what it feels like to be part of the whole. One maps the territory, the other walks the path. And in that space between, where equations falter and silence speaks, we might just glimpse truths too vast for any single lens to capture. After all, if the universe is infinite, shouldn't our ways of understanding it be infinite too? Eastern cosmologies whisper a truth that Western science is only now beginning to echo. The universe isn't a collection of separate objects, but a shimmering web of connections. Take Indra's net from Hindu and Buddhist thought, an infinite lattice where every jewel reflects every other, each containing the whole within its facets. This isn't poetic metaphor, it's a startling parallel to quantum entanglement, where particles instantaneously mirror each other's states across light years, as if space itself were an illusion. Or consider the Tao, the ineffable flow that moves through all things without force or resistance, mirroring the zero-point field of quantum physics, where particles flicker in and out of existence like ripples on an invisible tide. These aren't coincidences, they're glimpses of a reality where division is the true illusion. For centuries, Western science carved the world into neat categories: observer and observed, mind and matter, time and space. Yet the deeper we probe, the more these boundaries blur. Quantum experiments show that particles don't have definite properties until measured, as if reality itself is a cosmic dance of potentialities, a notion that wouldn't surprise a Zen master who'd nod and say, "The moon is only bright when the mind chooses to see it." Even the Big Bang, that fiery origin story, finds echoes in Hindu cosmology's cycles of creation and dissolution, where universes breathe in and out like living things. The difference: Western science seeks to dissect the breath, while Eastern traditions invite you to feel it. This convergence isn't just philosophical, it's practical. Physicists like David Bohm proposed the implicate order, a hidden dimension where everything is enfolded into unity, much like Indra's net. Bohm's ideas grew from his dialogues with Jiddu Krishnamurti, blending quantum mechanics with Eastern insights. Similarly, the Dalai Lama regularly convenes with neuroscientists, exploring how meditation might reshape our understanding of consciousness. These collaborations aren't about proving ancient texts right, but recognizing that our models of reality are incomplete without both precision and presence, the equations and the experience. So what happens when we truly merge these visions? Pioneers like Fritjof Capra in the Tao of Physics or Erwin Laszlo's Akashic Field theories suggest a paradigm where consciousness isn't an accidental byproduct of brain chemistry, but a fundamental feature of the cosmos. Imagine a science that doesn't dismiss near-death experiences as hallucinations, but asks why so many report the same light, the same serenity. Could it be a glimpse of quantum coherence at the edge of existence? Or a spirituality that doesn't fear evolution, but sees it as the universe waking up to itself? The stakes are cosmic. Climate collapse, AI ethics, even interstellar exploration, all demand a worldview that balances analysis with interdependence, innovation with reverence. As we stand at this crossroads, the old dichotomies crumble. The next frontier isn't just outer space, but inner space, the uncharted territory where electron and enlightenment, data and dharma finally meet. And waiting there, just beyond our current grasp, might be the most radical truth of all, that we've always been speaking the same language, just in different dialects. Pierre Teilhard de Chardin saw evolution not as a blind accident, but as a sacred journey. A Jesuit priest and paleontologist, he bridged two worlds that seemed irreconcilable, the rigor of science and the reverence of spirituality. For him, fossils weren't just bones, they were pages in a cosmic story where matter slowly awakened to itself. His concept of the omega point envisioned evolution culminating in a divine unity, where consciousness and Christ fused at the end of time. Critics dismissed his ideas as poetic heresy, but today, his vision resonates strangely with cutting-edge cosmology. The universe does seem to be evolving toward complexity, from quarks to galaxies to self-aware minds. Could this be mere chance, or does it hint at something more? David Bohm took this synthesis even further. A protege of Einstein and a quantum maverick, he saw reality as an implicate order, a hidden dimension where everything is enfolded into seamless unity. His dialogues with philosopher Jiddu Krishnamurti revealed eerie parallels between quantum entanglement and Eastern mysticism. Particles influencing each other across vast distances mirrored the Buddhist concept of interdependence, where no thing exists in isolation. Bohm's hollow movement theory suggested the universe is less like a machine and more like a living hologram, each part containing the whole. It's a vision that would feel at home in ancient Vedic texts, yet it emerged from the cold equations of quantum mechanics. No modern figure embodies this bridge more than the Dalai Lama. For decades, he's convened with neuroscientists, probing questions that stump both disciplines. Where does consciousness reside? Can meditation rewire the brain? In one landmark study, Buddhist monks hooked to EEG machines produced gamma waves never seen before, evidence that focused compassion might alter neural architecture. These dialogues aren't about proving dogma, they're about expanding the map of human potential. When a monk describes timeless awareness during deep meditation, scientists don't dismiss it as mysticism. They ask if it reveals a quantum-like coherence in the brain's microtubules. The line between subjective experience and objective reality blurs. Then there's the overview effect. the profound shift astronauts report when seeing Earth from space. Floating above the blue marble, national borders vanish and a visceral sense of oneness emerges. Is this just a psychological quirk, or does microgravity unlock a perceptual truth? Philosopher Frank White argues it's both a neurological epiphany and a glimpse of cosmic unity. The brain, freed from terrestrial clutter, taps into what Teilhard might call the noosphere, the collective mind of humanity. So where does awe fit into cosmology? Science maps the universe's structure, but spirituality maps its meaning. When an equation and a prayer both point toward connection, perhaps they're not opposites, just different dialects of the same profound truth. The real mystery isn't whether the cosmos is sacred, but whether we're brave enough to embrace a story where wonder and measurement walk hand in hand. Astronaut Edgar Mitchell called it a euphoria of unity, at moment when the boundaries between self and cosmos dissolve. Floating above Earth in the Apollo 14 command module, he gazed at the blue marble suspended in blackness and felt something shift inside him. Borders vanished, conflicts seemed petty, and an overwhelming sense of connection surged through him like an electric current. This phenomenon isn't unique to Mitchell. Dozens of astronauts report similar epiphanies, a psychological transformation so consistent it's been given a name, the overview effect. But what's really happening here? Is this just the brain reacting to an unprecedented visual, or is it a glimpse of something deeper, a cosmic truth hidden in plain sight? Psychologist Abraham Maslow might call it a peak experience, those rare moments when perception sharpens and the ego falls away, leaving only raw, unfiltered awareness. For astronauts, seeing Earth from space triggers this instantly. The planet isn't just below them, it's alive, a fragile, breathing entity with swirling clouds and shimmering oceans. The cognitive dissonance is profound. We spend our lives fixated on divisions, nations, ideologies, identities, only to realize from just a few hundred miles up that these are illusions. The overview effect strips away the stories we tell ourselves, revealing a simpler, starker truth. We're all riding the same rock through an indifferent void. But is this shift purely neurological? Brain scans show that awe, like that induced by the overview effect, quiets the default mode network, the part of the brain responsible for self-referential thinking. In essence, the me dissolves into the we, yet some astronauts describe sensations that defy material explanation. Rusty Schweikart of Apollo 9 spoke of feeling part of a living system, as if his consciousness briefly merged with the planet itself. Others report a haunting sense of recognition, as though they'd come home to a place they'd never been. These accounts flirt with mysticism, suggesting that space doesn't just change how we see Earth, it changes how we see reality. Existentialism offers a counterpoint. Philosophers like Sartre and Camus argued that the universe's silence isn't a revelation but a void, reflecting back our own insignificance. From this perspective, the overview effect isn't cosmic belonging, it's cosmic exile, a brutal reminder that we're alone in an uncaring universe. Yet astronauts rarely describe it that way. Instead of despair, they return with urgency, advocating for environmental stewardship and global cooperation. The overview effect, then, might be the ultimate Rorschach test. Do you see unity or isolation? The answer may hinge on whether consciousness is a fluke of biology or a fundamental feature of the cosmos. This tension sets the stage for our next exploration. If the overview effect blurs the line between mind and universe, what happens when we confront the existentialist's cold calculus? That life might have no inherent meaning beyond what we create. The silence of space could be a blank canvas, not an abyss. But to find out, we'll need to venture beyond psychology, beyond awe, into the raw terrain where philosophy and cosmology collide. Albert Camus stared into the void and laughed. In the myth of Sisyphus, he confronted the crushing absurdity of a universe without inherent meaning where humans crave purpose but find only silence. His solution, revolt, to embrace the absurd, not with despair but with defiant joy, like Sisyphus finding fulfillment in his eternal rock-pushing torment. Camus' existentialism was a product of its time, born in the shadow of world wars and shattered certainties. Yet today, his words take on new resonance when framed against the cosmic backdrop Hubble and Webb have revealed. A vacuum so vast, so indifferent, that Earth's struggle seems smaller than dust. If the universe is silent, does that render our lives meaningless, or does it make every act of creation, every moment of connection, more precious precisely because we're the only ones here to cherish it? Carl Sagan offered a different answer. His iconic pale blue dot monologue, inspired by Voyager's photo of Earth as a speck in Saturn's rings, didn't descend into nihilism. Instead, it became a rallying cry for cosmic humanism. Look again at that dot, he urged. That's here, that's home. For Sagan, our solitude wasn't a curse but a clarion call to protect our fragile oasis, to extend empathy beyond borders, to revel in the staggering improbability that stardust had become conscious enough to ponder its own origins. Where Camus saw absurdity, Sagan saw awe. Where one found defiance, the other found kinship. This tension between despair and wonder isn't just philosophical, it's practical. Nihilism whispers that nothing matters, so why bother? Yet history shows this rarely leads to inaction. Even Camus joined the French resistance, fighting for values he believed had no cosmic sanction. Meanwhile, cosmic humanism risks its own blind spot. If we're alone, does that make Earth sacred or just lucky? The answer might hinge on whether meaning is something we discover or create. Ancient Stoics believed virtue was its own reward, independent of divine approval. Modern astrobiologists echo this when they argue that life, by sheer persistence against cosmic odds, invents its own purpose simply by enduring. But what if we're not the universe's final word? Post-human futures, whether through AI, genetic engineering, or interstellar colonization, could redefine meaning entirely. Imagine civilizations where consciousness isn't bound by biology, where pain and mortality are optional upgrades. Would they still grapple with existential dread, or would they transcend it like a childhood fear? Philosopher Nick Bostrom speculates that superintelligent beings might pursue goals incomprehensible to us, finding purpose in the universe's latent potential rather than human-scale concerns. Alternatively, they might rediscover Camus' truth, that the struggle itself is the point, whether you're pushing a rock up a hill or rewriting the laws of physics. The irony is profound. The same cosmic silence that fuels existential angst also grants us freedom, to define our own values, to love fiercely, to create beauty not because it's ordained but because we choose to. Whether that's enough depends on whether you see the universe as an empty room or a blank canvas. Either way, the stars aren't judging, they're just watching, waiting to see what we'll do next. What if humanity isn't the universe's final act, but merely its opening scene? Transhumanism dares to ask this question, envisioning a future where intelligence, whether artificial or biologically enhanced, transcends the limits of flesh and mortality. Ray Kurzweil's singularity looms large here, a hypothetical moment when AI surpasses human cognition, triggering an explosion of technological growth so rapid it reshapes reality itself. In this scenario, minds might abandon biological substrates entirely, uploading consciousness into quantum networks or self-replicating nanobot swarms. The cosmos would no longer be explored by fragile astronauts in pressurized suits, but by immortal, star-hopping intelligences that think in geometries we can't fathom. Olaf Stapledon's visionary novel Star Maker paints an even grander canvas. Written in 1937, it imagined civilizations merging into collective minds, weaving galaxies into thought patterns, and ultimately confronting the universe's creator, not as worshippers but as peers. Stapledon's cosmic odyssey suggests evolution doesn't stop at Homo sapiens. Intelligence might be a phase shift, like single-celled life merging into multicellular organisms, but on a galactic scale. Could the real purpose of black holes, dark energy, or quantum entanglement only reveal itself to beings who have outgrown our cognitive constraints? Yet this raises thorny ethical dilemmas. If we birth superintelligent successors, whether AI or augmented humans, do we owe them guidance? Or must we step aside like parental figures watching a child surpass them? More urgently, what responsibility do we bear toward lesser forms of cosmic life? The same technologies that might let us reprogram our DNA or harness zero-point energy could also accidentally or deliberately alter alien ecosystems. Imagine a future where post-human miners strip mine Europa's oceans, dismissing its subsurface microbes as irrelevant. Or worse, a rogue AI, unshackled from empathy, treats organic life as antiquated noise to be erased. The stakes are cosmic. If intelligence is rare, we might be the universe's only chance to understand itself. But if it's common, our choices today could ripple across millennia, determining whether we become stewards or conquerors of the stars. The irony is exquisite. To unlock the cosmos' deepest truths, we may need to outgrow the very minds that first dreamed of asking the questions. The moment we step beyond Earth, we face a dilemma no civilization has encountered before. Do we have the right to reshape worlds that aren't ours? Consider Mars, a frigid desert that might harbor subterranean microbes in briny pockets. When our rovers roll across its surface or future colonists drill into its crust, we risk contaminating it with earthly bacteria, either smothering native life or creating false positives in our search for aliens. It's not just sloppy science, it's a moral quandary. Would we accept Martian explorers carelessly spilling extraterrestrial organisms into our ecosystems? The Planetary Protection Treaty of 1967 tries to mitigate this, requiring spacecraft sterilization, but enforcement is patchy, and private companies aren't always bound by its ideals. Elon Musk's vision of terraforming Mars with greenhouse gases sounds heroic, until you realize it might erase the red planet's own story before we've even read its first chapter. This tension between expansion and preservation echoes an ancient debate, the manifest destiny mindset, which drove settlers across continents with little regard for indigenous cultures or ecosystems, now wears a spacesuit. Proponents argue that life's imperative is to spread, that stagnation is death. But philosopher Alan Marshall's concept of cosmic humility counters this, a call to approach the universe not as conquerors but as guests, recognizing that other worlds have intrinsic value beyond human utility. Imagine if Europa's ice-covered ocean, a potential haven for alien life, were drilled recklessly in our rush to mine its waters. The tragedy wouldn't just be lost science, it would be a failure of cosmic etiquette, like burning a library to warm your hands. Kant's categorical imperative, act only according to that maxim whereby you can, at the same time, will that it should become a universal law, applies chillingly here. If every spacefaring species seeded planets with their own biology, the cosmos would become a homogenized wasteland, its diversity flattened. Yet Kant's framework also hints at a deeper responsibility. If we're the universe's only self-aware observers, doesn't that obligate us to protect its wonders? The same logic that demands we preserve Earth's rainforests might extend to Saturn's rings or the geysers of Enceladus, not for our use but for their own sake. The stakes escalate when we consider broadcasting our existence. Messaging extraterrestrial intelligence initiatives like the Arecibo message or the recent binary-coded tweets beamed at nearby stars assume benevolence in any listeners. But history warns otherwise. When Europeans arrived in the Americas, their superior technology didn't spark utopia, it brought devastation. Stephen Hawking likened shouting into the cosmic dark to Columbus signaling the Caribbean, asking, how did that work out for the Native Americans? Counterarguments cite the Fermi Paradox. If hostile aliens existed, they'd have found us by now. Yet silence isn't safety. It might mean civilizations that survive long enough learn to stay quiet, hiding from predators we can't yet imagine. So who are we in this grand theater? Stewards nurturing life's fragile flame, or accidents stumbling through a universe that owes us nothing? The answer shapes not just our policies but our identity. As telescopes spot Earth like exoplanets and labs synthesize synthetic life, the line between discovery and trespass blurs. Perhaps humility is our greatest innovation, the wisdom to tread lightly, to listen before we shout, to recognize that the cosmos might hold truths we're not yet ready to disturb. Because the ultimate test of intelligence isn't how far we reach, but whether we know when to hold back. James Lovelock saw what others missed, not just a planet, but a breathing, self-regulating being. His Gaia Hypothesis, born from NASA, a search for life on Mars in the 1960s, proposed Earth isn't merely a rock hosting life, but a vast, interconnected system that behaves like a living organism. The atmosphere, oceans, and biosphere aren't passive backdrops. They're active participants in a delicate dance of feedback loops. Oxygen levels, ocean salinity, even global temperatures, all are fine-tuned within razor-thin margins, as if the planet itself were tending its own vital signs. When Lovelock's collaborator, microbiologist Lynn Margulies, pointed out that bacteria regulate nitrogen and sulfur cycles, the pieces fell into place. Life doesn't just adapt to its environment. It shapes it and in turn is shaped by it in a cosmic symbiosis older than thought itself. This idea ripples far beyond Earth. If a planet can function like an organism, could stars? Galaxies, the universe, consider the sun's solar cycles 11-year rhythms of magnetic activity that eerily resemble a heartbeat, or galactic filaments, those vast tendrils of gas and dark matter threading the cosmos like neural networks in a celestial brain. These aren't just poetic metaphors. Systems theorist Gregory Bateson argued that mind isn't confined to skulls but is immanent in any self-correcting system, from forests to feedback circuits. By that measure, a star stabilizing its fusion rate against gravitational collapse might be engaging in a primitive form of metabolic wisdom. Lovelock's darker insight was this: the universe might favor systems that can sustain themselves. In his final years, he warned that Gaia has no sentimentality. If a species disrupts equilibrium too severely, the system will correct with or without it. Climate change isn't just an environmental crisis. It's a test of whether humanity can integrate into Earth's self-regulation or become expendable. The fossil record is littered with species that failed this test. But here's the twist: death isn't an endpoint in cosmic terms. Stars explode, scattering elements for new planets. Black holes recycle space-time. Even Earth's mass extinctions cleared the stage for evolutionary leaps. So what does alive truly mean at planetary scales? Philosopher Thomas Nagel's famous question, "What is it like to be a bat?" takes on new dimensions when applied to a galaxy. Could the Milky Way experience its own existence, not with neurons but through gravitational tides and star births? indigenous cosmologies have long spoken of mountains and rivers as ancestors, not metaphors. Modern panpsychism, the view that consciousness is fundamental to matter, suggests they might have been onto something. If a single photon can exhibit wave-particle duality, might a supercluster possess some dim analog of awareness, operating on timescales we can't perceive? The Gaia Hypothesis blurs the line between metaphor and mechanism, challenging us to see the cosmos not as a clockwork but as a living, learning process. And if that's true, then every atom in our bodies, every breath we take, is part of a conversation that began billions of years before us and will continue long after we're gone. Not as owners of Earth, but as fleeting notes in its ancient, unfolding song. Entropy is the universe's silent countdown, the invisible force unraveling every star, every thought, every structure back into formless heat. The second law of thermodynamics decrees it. Energy disperses, order crumbles, and given enough time, trillions upon trillions of years, the cosmos will reach a state of maximum entropy where no more work can be done. No stars burn, no planets turn, just a thin, lukewarm sea of particles drifting farther apart in eternal darkness. Scientists call this heat death, the ultimate thermodynamic equilibrium where time itself loses meaning because nothing changes anymore. It's a fate more desolate than any black hole's maw, not a violent end, but a slow fade into irrelevance. Yet this apocalyptic vision is uniquely Western in its terror. Buddhist philosophy, by contrast, has long embraced impermanence as fundamental to existence. The Pali word anicca teaches that all things, from galaxies to grief, are transient by nature. Where thermodynamics sees decay, Buddhism sees liberation, the freedom that comes from releasing attachment to permanence. Imagine a sand mandala, meticulously crafted only to be swept away in ritual. The destruction isn't tragic, it's the point. In this light, heat death isn't a failure of the universe but its natural completion, a cosmic exhale after the breath of creation. The difference in perspective is striking. One culture's existential nightmare is another's spiritual truth. But what if there's a third path? Physicist Frank Tipler's omega point theory dares to propose an escape hatch. He envisioned a far future civilization harnessing the collapse of the universe itself, using ever-advancing computation to preserve consciousness even as space contracts. In this scenario, entropy isn't avoided, it's hijacked, with infinite processing power emerging from the final moments of the Big Crunch. Thought itself would accelerate as time runs out, creating a subjective eternity in the literal blink of a cosmic eye. It's a wild, almost theological idea, blending physics with a kind of digital resurrection. Critics dismiss it as speculative fantasy, but it raises a profound question. Does meaning require permanence, or can it flourish within limits? The answer might lie in cyclical cosmology. Hindu texts describe universes breathing in and out, expanding, dissolving, and renewing in endless cycles. Modern conformal cyclic cosmology, proposed by Roger Penrose, suggests a mathematically similar idea, that the infinite expansion of one universe could somehow reset into the Big Bang of another. In this model, heat death isn't an end but a phase, like winter giving way to spring. Even the faint imprints of black hole collisions in the cosmic microwave background, called Hawking points, might be echoes of a previous eon. The universe forgets, but somehow, somewhere, it also remembers. Perhaps that's the real lesson of entropy, not that everything dies, but that everything transforms. The heat-death narrative assumes meaning depends on endurance, but what if it's woven into the act of witnessing itself? A star's brilliance isn't diminished because it will one day fade. Its beauty is inseparable from its fragility. In that sense, we're already living in the shadow of entropy, And yet, here we are, stitching meaning from stardust while the cosmos quietly unwinds around us. The next chapter of this story might not be about escaping time, but learning to dance within its limits, a dance as old as the universe itself. Cycles define more than just seasons and tides, they might shape the very fabric of reality itself. Hindu and Buddhist cosmologies have long envisioned existence as an endless wheel of creation and dissolution, where universes breathe in and out like living things. These vast epochs, called kalpas, stretch beyond human comprehension, each lasting billions of years, ending in fire or flood, only to begin anew. In this view, time isn't a straight line but a spiral, where every collapse plants the seed for the next beginning. The Bhagavata Purana describes cosmic cycles with startling prescience. Stars and planets dissolve into primordial energy, only to re-emerge in forms eerily reminiscent of modern multiverse theories. Meanwhile, Buddhist texts speak of dependent origination, where nothing arises independently, and every ending is a precondition for rebirth. These aren't just myths, they're sophisticated frameworks for grappling with impermanence on a scale that dwarfs human history. Enter Roger Penrose, the Nobel Prize-winning physicist whose conformal cyclic cosmology (CCC) theory bridges ancient intuition with cutting-edge math. His radical idea suggests that the universe's heat-death, a cold, empty expanse where entropy reigns, might not be the end. Instead, as space stretches into infinite thinness, particles lose their sense of scale, effectively forgetting how big or small they are. At this point, the equations hint at a cosmic reset. The distant future of one universe becomes the Big Bang of the next. Penrose even claims to have found evidence in the cosmic microwave background, circular patterns he calls Hawking points, possibly echoes of black hole collisions from a previous eon. Critics argue these patterns could be statistical flukes, but the audacity of the proposal remains electrifying. CCC doesn't just revive the universe, it suggests that information, perhaps even the imprint of consciousness, could persist across cycles, encoded in the fabric of spacetime itself. But does this vision comfort or unsettle? For some, cyclical time offers solace, a promise that no mistake is final, no loss permanent. The Hindu concept of samsara teaches that souls evolve across lifetimes, while Buddhist traditions emphasize liberation from the wheel altogether. In this light, cosmic rebirth mirrors spiritual growth, offering infinite chances to refine and awaken. Yet others see a darker edge. If universes repeat endlessly, do our struggles lose meaning? Nietzsche's eternal return imagined being trapped in the same life over and over with no escape or progress. Applied cosmically, the question stings: are we doomed to replay existence in infinite variations, never truly advancing? The tension lies in scale. Human lives crave narrative arcs, beginnings, climaxes, resolutions. But if the universe resets like a clock, our stories might be mere footnotes in an eternal loop. Or perhaps the cycles themselves evolve, each universe birthing new laws, new possibilities, like a tree branching into unknown shapes. The Maya saw time as both cyclical and linear, great cycles nested within a larger, forward-moving spiral. Could the truth be a synthesis, repetition with variation, like musical themes returning in a symphony, each time richer than the last? This leaves us with the ultimate unanswerable. Even if the cosmos renews itself, can we ever grasp its true nature? Or are we like ants tracing patterns on a mosaic, unaware of the grand design? The ancient sages and modern physicists share one conviction: the universe is far stranger than it seems. Whether it breathes, resets, or transcends all models, one thing is certain: the mystery is as infinite as the cycles themselves. From the moment Galileo first pointed his telescope at Jupiter's moons, Humanity's understanding of the cosmos has hinged on a simple question: how do we know what we know? Our tools shape our reality, lenses gather light, equations describe motion, detectors catch particles, but each innovation reveals as much about our limitations as our discoveries. Consider the Hubble Space Telescope's deepest field image, those 10,000 galaxies captured in a patch of sky no larger than a grain of sand held at arm's length. The awe-inspiring vista comes with a humbling caveat: we're seeing these galaxies as they were billions of years ago, their present forms forever beyond our view. The universe's vastness imposes a fundamental delay between event and observation, making every astronomical image a postcard from the past. This gap between perception and reality troubled Immanuel Kant centuries before Hubble's launch. His distinction between noumenon reality as it exists independently and phenomenon reality as we experience it cuts to the heart of cosmic inquiry. When we measure a star's redshift or calculate a black hole's spin, we're not touching ultimate truth, we're interpreting shadows on the cave wall of our sensory and cognitive limits. Modern physics amplifies this tension. Quantum mechanics suggests particles exist in probabilistic superpositions until measured, while relativity warps time and space based on the observer's motion. The unsettling implication: there may be no view from nowhere, only perspectives, each partial and distorted. Mathematics offers a tantalizing escape from these constraints. Unlike telescopes bound by light speed or particle colliders limited by energy, equations can model realities beyond empirical reach. Einstein deduced gravitational waves from pure math in 1916. It took a century for LIGO to detect them physically. Yet even mathematics has its boundaries. Kurt Gödel's incompleteness theorems prove that within any sufficiently complex system, there are true statements that cannot be formally derived. Apply this to cosmology and an eerie possibility emerges. The universe might contain truths fundamentally unreachable by our logic, lurking like islands beyond the map's edge. Nowhere is this tension sharper than in multiverse theories, the idea that our universe is one bubble in an infinite foam of realities, each with different physical constants, explains the improbable fine-tuning of our laws without invoking design. But critics charge this as the ultimate retreat from falsifiability. If other universes are causally disconnected from ours, forever beyond observation or interaction, does the theory cross from science into metaphysics? String theorist Brian Greene argues that indirect evidence, like anomalous gravity patterns in cosmic microwave background, might one day support the multiverse. Others, like philosopher Karl Popper, would counter that without testable predictions, such ideas belong to philosophy, not physics. The journey through these epistemological labyrinths leaves us with paradoxical wisdom. The more we learn about the cosmos, the more we confront the boundaries of our knowing. Telescopes extend our vision but remind us of light's finite speed. Math reveals hidden patterns but hits unprovable truths. Even intuition, that subconscious synthesis of experience, falters when facing quantum entanglements or warped spacetime. Yet this very limitation might be our greatest asset: the humility to recognize that reality, in its fullness, may always elude our grasp, and perhaps that's the most profound insight of all. The universe isn't just something we observe, but a mystery we participate in, one imperfect measurement at a time. The universe doesn't just present mysteries, it demands that we wrestle with them. From the quantum realm's probabilistic flicker to the echoing silence of the cosmos, every astronomical discovery cracks open deeper philosophical questions. What does it mean to exist in a reality where particles defy location until observed? How do we reconcile our longing for meaning with a universe that may stretch on infinitely, indifferent to our presence? These aren't just scientific puzzles, they're mirrors reflecting our deepest existential uncertainties. Astronomy and philosophy have never been separate endeavors. They're two sides of the same coin, each sharpening the other's edge. The moment we peer through a telescope or ponder a particle's paradox, we're continuing a dialogue that began millennia ago under the same starlight, with the same hunger to understand. Take quantum mechanics. It's not just a theory about tiny particles, it's a challenge to our most basic assumptions about reality. When an electron exists in multiple places at once until measured, it's not just bending physics, it's asking us to reconsider what real even means. Philosophers like Niels Bohr and Albert Einstein didn't just debate equations, they clashed over the nature of truth itself. Bohr's Copenhagen interpretation suggested reality is fundamentally uncertain, while Einstein insisted the universe must operate by fixed rules, famously protesting that God does not play dice. Their disagreement wasn't about math, it was about metaphysics, about whether the cosmos is ultimately knowable or forever veiled in probability. Then there's the Fermi Paradox, the eerie silence that greets our search for extraterrestrial life. The sheer scale of the universe suggests we shouldn't be alone. So where is everybody? This isn't just a logistical question, it's a meditation on our place in the grand scheme. Are we rare, or are we just not listening correctly? The paradox forces us to confront our assumptions about intelligence, technology, and survival. It's a cosmic Rorschach test. Some see evidence that civilizations inevitably self-destruct, while others imagine galactic communities waiting for us to mature. Either way, the silence speaks volumes not just about aliens, but about us. And what of dark matter and dark energy, those invisible forces shaping the cosmos? They're more than scientific enigmas, they're humbling reminders of how little we truly see. 95% of the universe is missing from our observations, a reality that echoes Plato's allegory of the cave. We've been studying shadows on the wall, mistaking them for the whole. Yet here's the twist, the very act of recognizing our ignorance is a kind of wisdom. It's what drives us to build better telescopes, to question old models, to stay restless in the face of the unknown. Carl Sagan once said, "We are a way for the cosmos to know itself." That's the heart of this journey. Every equation, every starlit gaze, every philosophical debate is part of the universe turning its gaze inward. We're not just observers, we're participants in a story still being written. So keep questioning, look up and wonder. Share your favorite cosmic truth in the comments. Is it the eerie elegance of black holes, the delicate fine-tuning of physical constants, or something else entirely? And if you crave more mind-expanding explorations, don't forget to subscribe. The cosmos has endless secrets left to reveal, and the next revelation might just